data frame manipulation. It's an extended part, I would say, but here we'll try to understand some different techniques. All right. For that, what we will do, this is going to be interesting, I would say. Let's import this NumPy and pandas. Now let's create some data, our own data, right? So I'm creating a matrix and I'm creating a list of names and some age, height, and weight, some data basically, right? So let's first run this, keep all those data in this particular object in the matrix data, row label, column headings. Then we'll use these objects and create a data frame, right? So what I'm going to do, I am going to first take this matrix data, then row labels for the index and column headings, right? Data, index names and column names. The whole thing I'm going to convert into data frame. Let's print that data frame. This is how it looks like, a simple data frame, right? Here in this data frame, we have an age, height, and weight of some students or some candidates. Raju, Pandey, Srini, Sunil, Ashok. So these are all what our own names, I mean index names, which we have given, user defined index names. So Raju is having, Raju's age is 22 and his height is 66 and weight is 140, right? Similarly for other candidates. So let's say that this data related to some let me find out which example I can give. So let's say that age, height, weight, so some selection, army selection, let's put that way, army selection or a police selection or something related to a government sector, right? Police, Navy, Army, or BAF, BSF, whatever the related, right? So we have collected candidates data. So yeah, there could be many columns we can write. We can write many columns: phone number, email, father name, mother name, and address. And there are many things we can collect, but here we are trying to keep the data very simple so that we can understand it the best possible way, right? So this is our data. Now, if I want to select only the height, sorry, my bad, only the height. Your data frame, the whole thing is data frame, and select that particular column. This we have seen and it's pretty straightforward, right? So yeah, Raju height is 66, Pandey and other candidates. That is fine. Now, if I want to check the type of height, I can just write a type and select the column name. It will give what type of it is. Anyway, we know it is an integer. So it's a data type, but here we are trying to check only the type. Okay, data frame or NumPy, it's array or a list or tuple, that kind of thing. Then if I want to select multiple columns, df, you are going to have one square bracket, and within that you are going to pass your column names as a list. This is very, very important. Here we are selecting only one column, and we don't have, because it's only one column, we don't need to pass it as a list. Here we are going to fetch multiple columns, so I need to pass those column names as a list, right? So height and weight, right? So yes, you will be able to fetch it, height and weight. So height is basically only series because it is having only one column. It is giving me the type is series because it has only one column. And we have selected multiple columns. Yes, height and weight. So Raju height is this and weight is this, Ashok height and weight and things like that. If I want to access any particular column, I can also write this way, df dot height or weight or age. I can also write dot. I don't need to specify this square bracket. Rather, I can use df dot age. But it is not recommended, but it is possible. It is possible. Yes, you can use this dot only to fetch only one column. You cannot say that df dot age dot height. It doesn't work. Only for one column you can do that dot. Another way of fetching a data. Right? Now let's understand slicing particular element. So first of all, let's try to use this log method, right? df dot log. So if I want to see Raju details, locate index name. Index name. So I can give that. So here you will get, this is Raju age, height and weight. Name is Raju. So just you try to compare our next result. So you will see something different. So here, since I selected only one candidate details, it is giving me age, height, weight. You see, these are the column names, right? And these are the data. Fine, that is one thing. And there is something called ilog. ilog, index location. Index location. Here I am going to give the index position. Index position 0. 0 is what? 0 is Raju. 0, 1, 2, 3, 4. So I am saying index location, ILOC. Here I have given index name. If you are giving index position, you can say I location, index location. It is also going to fetch the same data. Right? Same data. Here I have passed index position. Log, ilog. You can see the difference here. Here I am passing the name and here I am passing the position. That is the difference between log and ilog. Next. Now, suppose say that I wanted to see a particular candidate height or weight or age. So what we will do, first we'll print this. Okay, give me a second. This is the data set. Now, I wanted to see Pandey height. How will I be able to do that? So df dot log, use the index name, comma, which column you want to see, height. Index name and column. Index, column name. So you will be able to see only Pandey's height. So execute this. So this is basically his height. You can see that. Similarly, you can fetch anyone's data. So now I wanted to see Ashok height and weight. Height and weight. This guy height and weight. Right? So let's write this code. df.log index name, comma. Now I have to pass the column as a list because I am trying to fetch multiple columns. So I have to pass it in the list. I want height and weight. Yes, let's execute this. Now you can see name Ashok, his height is 62, weight is 152. 62 height and 152 is weight. So these weights are in terms of a LB, okay, or a pound you can say. So not in kgs. Don't think that they are too fat or things like that, but they are in terms of a LB, right? So that's how you can interpret. So this way I will be able to fetch any particular guys, any particular candidate data. Be it is hundreds of columns, you just need to pass it. Whichever column data you want to see for any candidate, so you will be able to fetch it. Straightforward. Now, if I want to, okay, we have seen that particular guy. What if I want to see multiple candidates, Srini and Sunil, both candidates height and weight? So yes, we can do that as well. So I'm going to say df dot location or log. In this whole is the main square bracket. Within that, so these are basically indexes, index names, because I have a comma here, and these are columns. So which index names we want to select? Srini and Sunil. You have to note this square bracket, right? Srini and Sunil. These two candidates, I want to know height and weight. If you have hundreds of students or candidates, yes, just add those names, that's all. And if you have another few columns you want to fetch, yes, you keep going, keep adding those column names. Let's execute this. Now you see this, earlier we were fetching only one candidate, right? So it was coming like this. Now I'm fetching two candidates. So see how smartly it is trying to put that data, right? So Srini Sunil is height and weight, right? Fine. Pretty straightforward. Now let's try to understand some conditional data fetching. So based on some condition, how to fetch the data. Let's go back to that use case. Okay, some army selection or police or BSF or things like that. So there, obviously they prefer more on physical fitness, right? And the age, your marks and all takes a back seat when it comes to, you know, things like this, like army or a police. Yes, they do give importance, but more importance will be given to your physical fitness and what is your age and all. So now let's say height is the important factor. Height is the important factor. I want the candidates, I want to see the candidates whose height is greater than 65 inch. Because less than 65 inch, there's no eligibility for such candidates whose height is less than 65. This is the cutoff inch. So it can be 80, 70, but minimum height criteria is 65 inch. So I want to see only those candidates. Suppose say your candidates are thousands of candidates. It is very difficult to go through each and every candidate and see their height, right? So what I will do, I will just select the column and I will say greater than 65. Right? So this way I will be able to sorry about that. So this is going to give me Raju, Pandey and Sunil. These candidates' height is greater than 65. Right? So it will fetch their age, their weight as well, based on what? Based on height condition. Suppose say that there are multiple conditions. Yes, height should be at least 65 and weight should be more than 145. Right? So I will be able to store this condition in one variable, this condition in one more variable. So another way of fetching a data, another way of adding a conditions. So I'm calling it as bool df1. You can give any name. Let's execute that and store these conditions. Now I want to see those candidates whose height is greater than 65 and weight is 145 pound. So what I will do in this data frame, this is our data frame. In that, I want condition 1 to be satisfied and condition 2 also needs to be satisfied. This is the first condition and this is the second condition. Pick the data from this data frame. Right? So let's execute this. So these two candidates are eligible for whatever the selection. So you can check their height is greater than 65, both the guys, and their weight is also greater than 145. This is 148 and 160. Let's say that in this data frame, based on one condition, suppose I have some condition, right? Based on this condition, I want to select columns. Condition is different, condition column is different. Based on this condition, I want to select particular columns. So like, what is this bool df1? This is height. I'm saying based on this condition, what is where height is greater than 65 inch, I want to select age and weight. Our condition is on height, right? Our condition is on height. Look into this one, bool df1. Based on height, I want to select age and weight because minimum criteria is greater than 65 inch. Minimum criteria. I know that for sure, whichever candidates are there, I'm going to filter, right? So based on this condition, I don't care if they have a 70 inch, 75 inch or 80 inch. I don't care. Minimum is 65. Whoever height is greater than 65 inch, I want to see their age and weight. What if age is like a 40, 50, 60, right? So always some candidates will apply for all kinds of jobs, irrespective of their age. But for some jobs, age will play a very important role, right? So I want to see their age and their weight. Yes, their height may be 65 inch. What if their weight is say only 40 kg, right? They are underweight. Maybe they are not healthy, right? So all these concepts we can apply. So based on 65 inch, so I want to see their age and weight. So that is basically we are trying to make up some story here so that we can understand better, right? So let's run it. So all these candidates, right, definitely they have a height greater than 65 inch. There is no doubt about it. And their age and weight I'm trying to see here. So their age 22, 42 and 35 and weight is 140, 148, 160. Weight is fine, but only Pandey height, Pandey age is 42. So maybe we can eliminate him, right? From our list, from the selection list, we can just remove that. He is not eligible because he is over age. So this kind of strategies or a kind of analysis we'll be able to make based on different conditions and what kind of columns you want to see, data you want to see. So we are trying to work on different criteria, different conditions, different logics we are applying to fetch the data, right? Let's print our original data frame, right? Now, let's look into this. So here, say age, height, and weight. I want to reset index. I want to reset the index. So how it is going to work? So let's execute this. When I say reset index, what happens? It is going to bring in its original index positions. Your index will remain same, but these are the index positions. Index positions it is going to show you. So that is basically what reset underscore index. You may ask that, okay, so should we keep this or not? It is up to you. What if you don't want to keep it, right? So you can press shift and tab. You have a parameter drop, right? That drop will help you to remove your index. We will see that part we will see here. Okay, no worries. So this basically we are trying to understand here reset underscore index. It is going to bring in its own index positions. All right. Now again some conditions here. So I want to see the candidates whose age is less than 35, because more than 35 age is over, they are not qualified for some positions, right? So I want to filter those guys. So yes, I'm going to apply that condition. DF data frame, in that select the age and the condition is less than 35. So this is the condition, and this is basically I'm giving the whole data. In that data, you after applying this condition fetch the remaining records. So these are the guys whose age is less than 35. All right. Now reset index. The reason why we are resetting index. Now if you look into this, right, let's say Raju is 0, Srini is 2, say 0, 2, and Ashok is 4, 0, 2, 4. These are the index positions, right? So now I wanted to, after selecting, I don't want this index position to be scattered, like in between some names we have removed, right? So our index position should be in the order 0, 1, 2 should be in the order. So that is why I am going to reset the index, so that next time this Raju, Srini, Ashok will have 0, 1, 2. Earlier we had 0, 2, and 4. After removing these two guys, we left with only 3 records or 3 rows. So I'm going to reset so that it looks better. So that is why I'm going to say this is the DF, take it and reset the index. Now I'm going to say drop equal to true. Drop equal to true means whatever the index names you had, you are going to drop it. You are going to drop that. That is basically why we use reset index. So now our index positions looks good, 0, 1, 2. If you don't want to drop these names, yes, don't give anything. Don't give anything. If you want to keep it, keep it. If you want to drop, you have to have this parameter set to true. It's up to you. You want to keep or you want to drop it. For both, we have options. Right? Fine. Everything is done. Now say that let's change our requirement. So these are the candidates, age, height, and weight. Now I wanted to add their profession, right? Profession, new column, engineer, student. So this is profession. So student, teacher, engineer, right? So if I want to add it, yeah, create and the respective data. We have seen this kind of an example earlier, right? Dot split and all. So let's create this, and we have student, teacher, engineer. Right? So don't worry about this. These are just warnings. Okay, don't worry. Sometimes because of a version mismatch and things like that, it will give some warnings. Don't worry about that. So, and also we have some libraries to avoid these warnings keep coming. Okay, I will talk about that. Fine. So I have got a profession here. Now you want to set profession as index. If you want to set profession as the index, yes, you can do that. So what I'm going to do, DataFrame dot set. See, there is something reset and set. Okay, we have seen reset. Now we are saying set underscore index. When I say set underscore index, it means that whatever the columns available in your data frame, pick any column and set that as an index. So set index, which column? So I'm going to say professional column. This column I wanted to set as an index. That's how you can interpret this. Let's execute this. Now your profession is set to index. Profession is set to index. Student, the student age is 22, height and weight, teacher age, engineer age, height and weight. So this way, whatever the column you want to make it as an index, you have to set it to index, set underscore index. Reset means, reset is different, okay? Reset means it is going to show you the original index positions. That is the difference. Don't get confused with that, right?